Okay, so I will start with the presentation. So I will present my postdoctoral project that was funded by the Academy of Excellence of University of Côte d'Azur. And the topic of the postdoctoral project is extendable model for describing user profiles. So just one word about this type of postdoctoral projects. One condition to apply for this type of funding is to join another university team than the one that we were present before. So before I was in Comrade team, in Cairo Swimming's team, working with embedded systems. So just to give an overview of the presentation, so I will start talking motivating why user profile matters. Then I will present the research problems and the objective of this postdoctoral research. Then state-of-the-art results that were performed. Then I will focus on extracting user profile dimensions and present a proposal of user profiling meta-ontology. And finally, I will show the motivating example and how it is envisioned to use of this ontology and conclude. So why user profiling matter? So we have in software development user-centered design practices that are standardized, and basically they focus on assessing and evaluating usability and user experience of the software systems, focusing on effectiveness, efficiency, satisfaction, and dimension describing users' perceptions and feelings. So this process focus on planning the human-centered design process and then understanding and specifying the context of the use of the intended interactive system. And in a third phase, we need to specify the user requirements. So we need to understand what is the user profile or intended users of the system. To produce design solutions that meet requirements and evaluate finally this system according to the target user profile. So we define user profile as a representation of an individual user that can be real or fictional, or a group of users. Correlated term or used in with user profile is a user model that is seen as the instance of user profile. So when we have a certain data structure and can be dynamic or static. So user profile is a main component that is needed for evaluation, personalization, and adaptation of the interactive systems. It empowers establishing strong links between different human factors and the application domain of the target software. And it leverages data on different human activities, their emotional and physical states that can assist developers how to model and reuse and share user profiles. So there exist three techniques for describing user profile, namely user roles, personas, and user profiling. And there are different methods actually how to access user profile or gather data regarding the users. Mainly they are divided to be qualitative and quantitative, and some examples are like interviews, questionnaires, focus groups, and so on. So first technique I will introduce is actually using user roles. So here we focus on the task and responsibilities of the user. So this technique collects the attributes that characterize a certain user population and their intentional interaction with the system. So common approach is to present it in a user task matrix, actually thinking on who is doing what and how often. So we have down the example giving different type of user roles, like patients, their families, novice clinicians, and expert clinicians. And all of them have a certain task that they want to do when they are interacting with the system. We need somehow extract or describe their profiles and what are the differences in between certain characteristics, and also understand what are the relevant attributes that can help us to understand and evaluate the target system. Other technique is persona. It is basically stereotype description that tells the meaningful story that describes user behavior and their needs. So this technique is based on data gathered through user research. And actually, it is mapping user profiles that represent a few important classes of the target user. So down we can see one example of how persona is presented. So we can have a certain image representing certain demographical data, describing the target goals, some type of frustrations and motivations of this specific type of user. And yeah, this user can be not always representing some real users, also the fictional user of the system. And the final technique is called user profiling. So we can sometimes mix it with the notion of user profile, but user profiling is a specific technique that actually focus on getting the differences among individuals in the population. So here the focus is to collect different user characteristics that can be useful for us to identify user groups. And these can be personal characteristics like age, gender, lifestyle, special skills, physical abilities, and so on. Also task-related characteristics. So what are the goals and motivation? What is the usage and training or experience of the target user group? And finally, geographic and social characteristics like the location, cultural and social circumstances, and their connection and societies in which they operate with the target software. So I'm going back to the definition of the user model. So user model is a data structure used to capture certain characteristic about an individual. So we use user profile to actually describe all the characteristic of the target user. When it is implemented, it is becoming a certain software artifact or a component that can be integrated with the rest of the software system and serve for the evaluation. We have 4 main categorizations of the user model. So of the component that is deployed, it can be static. So the ones that we don't change ever again. Dynamic, that can be updated and take the current user data into account. Then we have a stereotype-based model, and this is based on demographic statistics that users are classified into common stereotypes to which system adapts, and this is currently the most used practice in evaluation of and adaptation of the software systems. And finally, we have highly adaptive user models that are targeting to represent one particular user, so one individual, and to allow very high adaptability of the system to this individual. However, problem with this type of user model is that we need to gather lots of information first to be able to use this type of model. So now I will go to present research problems and objective. The problem is how to describe the users. So there is still no uniform way for describing users. So there is lack of the formalization, and it is very difficult to compare user groups from the different studies and different domains. It is hard to integrate and reuse knowledge about user that was obtained in while developing one system, and when we go to another system. And finally, collected attributes can evolve over time. So one example is the gender. So historically, we were always assuming, okay, we can have just a female and male user, and this doesn't change. And today we are witnessing that it's becoming socially acceptable, even this attribute that we were considering like fixed, that can change with the time. So important problems to address is how to extract the knowledge to describe the user. So every user is a unique individual or the variation in the population, and sometimes their tasks and responsibilities might be more important than some individual preferences, but not always. So today we use a stereotype view of users, and it is dangerous, but still it is a necessary trade-off, especially for analyzing and generalizing solutions. So the objective of this postdoc is to acquire knowledge about different user modeling techniques and to provide extensible, technology-independent, computer-readable user profile. So I divide this into 3 research objectives. First is to specify computable user models. Second is to accommodate large variety of attributes describing users. And finally, to create a platform that can extract and share knowledge about the users. So I started with the state of art, basically using a Google Scholar platform to search for the existing work on the user profile, user profiling, user groups, user modeling, and personas. And the type of paper I was more focusing is to gather all the existing surveys, literature reviews, and existing ontologies. So I searched for papers in 2005, and basically I obtained 14 good surveys and literature reviews describing these topics, and 9 ontologies, of which there are 7 individual ontologies because we have some published several times. So based on the Eke, who performed the extensive systematic literature review on user profile modeling, he described user profile modeling as a process of building a computational model using extracted features that can predict user needs and preferences. And he highlighted several open research challenges in user profile modeling. So one of them is to be language independent, that ontology representation is highly supported. There is a need for general purpose profile. There is need to work more on dynamic profiles. Also to be able to distribute the created profiles to secure user profiles. So think about the privacy of the data, and prediction regarding the location, and for fake profile detection. So we support this idea of building ontology-based user profile, and Sonsovsky already in 2010 did a survey where he was contributing to this idea, saying that the ontology-based user profile can enable system reasoning across multiple profiles, so we can have a socially adaptive systems, and systems can benefit from complex interference of multiple ontologies representing different knowledge. So I analyze 9 ontologies, or 7 individual ontologies that are described in this table. So as we can see, there is only one ontology that is general, that is a general user modeling ontology. Other ones are all domain specific. So they address knowledge management system, personal information management, requirement engineering, user-centered design, and the last 2 are more focused on the user model itself. So grapple ontology focus on understanding specificity when we create user model pipes or services to connect it to semantic web, and user modeling meta-ontology that was provided with Yultson actually examine the different techniques in user modeling field. First step is to actually understand what are the basic dimensions and agree what are the dimensions, how to describe the user profile. So we have 5 ontologies actually presenting different user profile dimensions. And we can see that also 4 of them are presenting certain instances based on the provided ontology. So these 2 present partially how certain part of ontology can be instantiated, while we have 2 examples where the complete ontology instances are presented in the article. And we have different implementation techniques. So we can see that they use all count, framework, and protege. However, we can see also that these ontologies are from 2005, and the last one is in 2015. So there are no newer information on user profile ontologies, and the existing implementation that are linked in the paper are not available. So all the links are broken. We are also aware that there are 2 widely used ontologies that can help on describing user profile, mainly friend of friend, so to describe the social relationships in the web, and the person ontology from schema.org. So to have a little overview of existing ontologies, so this is how the GUMO ontologies is presented, and actually this is a static ontology that have examined over 1,000 groups of auxiliaries, predicates, and ranges. So this ontology is only one that actually is general and widely covers all the properties and attributes that can be used to describe the user. As I say, the GUMA is not available since 2015, but I managed to contact the author and receive one version in all from this ontology. Further, we have a user profile ontology that have several main dimensions here, actually encapsulating basic user information, characteristics, their abilities, and other things that I will describe more in detail later. This ontology is static and is based on the user profiling case studies. Then we had the so-called holistic persona ontology, where Anvari was actually building a persona user in terms of the different roles and trying to characterize based on different dimension certain characteristics that are important for different case studies for these roles to evaluate different systems. And we have a persona ontology from SIM, who actually also focused a lot on describing behavior ontology and encapsulating also requirements in the system regarding the use of the system. He presented also his ontology in terms of the class diagram. So what are the conclusions? So static properties are broadly analyzed, especially with the GUMO ontology. Existing examples do illustrate user modeling process with ontology, so we find some examples. And requirement engineering and knowledge management domains are well covered in the given case studies. However, weaknesses is that they are static, so they don't address how the property can change with the time, with the new data retrieval. We lack support of dynamic properties, so temporal features, so features changing in matter of milliseconds, for instance, using time series database. So most of them are domain specific, so it is difficult to share and reuse existing ontologies and user models. There is no publicly available operational and usable implementation of the ontology from the academic papers. And they are primarily adopting top-down approach. So none of the ontology consider the bottom-up approach or starting from the existing data. Now I will focus on a process of extracting user profile dimensions. So we need to start from understanding this. So I focus on the 5 ontologies that I presented that were actually addressing dimensions, and also 2 big surveys for user modeling and ontological techniques, and survey of user profiling that also discuss different user profile dimensions. So these were proposed dimensions which are now published. So first I am focusing on the general dimensions, so the dimensions that are domain independent and that can enable a reuse of different user profile models in between domains. So we have demographics, where we actually encapsulate all the information commonly used for segmentation and categorization. We have characteristics, where we encapsulate general physical traits and personality traits. We have a role dimension, where we encompass user profession, occupation, affiliation, and their responsibilities. And further, we have ability. Ability represents users' proficiency and expertise in performing various tasks. Then we have dimension of relation, and this is a connection or association with entities like things, their contacts, and their contact to different organizations or the entities. And finally, we have a human state dimension that encompass users' well-being, emotions, mental state, psychological indicators, motion, and facial expression. So basically, we get these dimensions from previous ontologies. So first thing, we can think also about how often the property change in these dimensions. So when I go more to the left, we are expected more rarely that the properties and inside attributes will change, and more to the right, with the human states in the end, we expect that these properties can change very often. I created here a small legend, but we can see, so the green areas are where the identical name are existing in the proposed ontologies, plus the light green has another dimension which is encapsulated in the same one. Further, we have yellow areas where there is the same concept, but so the attributes or properties that are inside of persona concept are actually ones that we want to in demographics. And the gray areas are which are dimensions that are not addressed by existing ontologies. So basically how I get to this, when I put the ability example from Sim Technology, he had actually 4 different dimensions describing this. First name ability, other describing knowledge, language proficiency, and education. And a good example with the Sim, because he had a full implementation example of his complete ontology. And when I go to the properties that he was actually putting in different dimensions, we can see that we can map them to one single concept. So this process was done with all ontologies and their implementations. And now I will go through domain-specific dimensions. So these dimensions encapsulate attributes and properties that are specific for a particular domain where the interactive system is developed. So the general properties, of course, somehow will need to be related to be obtained with certain domain properties. So let's go back to the categories. So we have a behavior. So here we analyze user activity patterns, their interaction sequence, and frequency of actions. Then we have interest, that are topics or subjects that attract users, or expertise they are finding engaging. So then we have their preferences. So that are individual choices or some options that they favor, how they want to use them or work with them. And then we have a goal task dimension that reflect the intended outcomes and desired results during the interaction with the system. We have also environment. So this is a physical location, social context, and technological infrastructure. So this is basically context in which the user is working with the intended software. And we have a final dimension proposed by SIEM that is requirements, where we map functional and non-functional requirements that user expect from the system. So when we go again to the mapping table, we can see that basically SIEM focused mostly on completely characterizing domain-specific dimensions. We have Hackman and Unvaried that were just working with the general properties. What is also good because they went deep in actually going first step in creating the general user model. And we can see that other people also had a certain considerations, especially regarding behavior, interest, preferences, and their goal and task. So now I will go to the proposal. So I call, so what we want to be able to create a user profile ontology. So by Eke, this approach can enable us sharing and understanding sharing of understandings among the users, and to reuse the domain knowledge. We can map profile information that had different schemas into unified system, and we can enable profile transformations into unified format. So if we think about ontology engineering, it is a part of model-driven engineering, and that is a technique that I want to use. So why? Because this can help us to create language-independent approach. It can help us to create a general purpose profile. So model-driven engineering can and study dynamic profile structure, so it can contribute to that and to be able to distribute the profile. So proposal and rationale is to enable sharing and reusing user profiles. So we need standardized domain representation, common vocabulary for domain of user profile. We need to provide guidance for developers and domain experts how to create this user profile, because common software engineers, domain experts, they don't know a lot necessarily about the human factors. And further, we propose development of the meta-ontology. So now we are still on meta level, that we want to enable the environment where we can make instances, so user profile ontologies that will be used in a certain project. We want to rely on knowledge graphs, RDF structures for describing user models, to allow the reasoning techniques and field relationship between data, and to use standards to have a data easy to operationalize and easy to disseminate. So via linked data and endpoints. We want to create federate models and ontologies, so enable linking of existing ontologies. So for start the examples that we found in the literature, and integration of existing data sources. Further, we want to describe general user profiles independent of the specific domain. So we want to have a clear distinguishment between domain of the software or system that is under development and the general properties of user profile, and to facilitate the analysis and extraction of domain-specific information. And finally, to enable generation of user model in runtime environment. So basically, this is a high-level proposal of the framework that I call user profile meta-ontology. We have several requirements imposed by the literature on generality, import of external data, integrating multiple ontologies, enhancing expression, enabling extendability, addressing the privacy issues, and enabling reasoning abilities. So today we have a lot of data coming from the web, IoT devices, empirical research studies, and also from the public institutions. So we want to be able to map and link this data to our ontology. We also want to be able to use existing domain ontologies, so having the user profile ontologies, we want to create environment that will use common techniques and enable retrieving information from the existing sources. And finally, to actually using model-driven engineering approach to generate user model component in runtime environment or the simulation environment, and to generate data storage. So platform that I decided to use is a part of Open Cesar project. So this project will enable to define UPMO using interrelated domain-specific languages. So domain-specific modeling languages are an essential part of model-driven engineering practice. And it enables us to represent the ontology DSL precisely using semantic web ontologies. It integrates information in engineering tools based on code generation and model transformation. So we inherit this directly from the platform. It supports us in information authoring, federation, linking, change management, and configuration management. And it also has a native support for system engineering process like Agile and continuous integration pipelines from the DevOps. So this platform already provide, and this is all platform is open source, so it is also possible to extend it and to make the our own extensions to the platform. Inside of the platform or the core of it, it's ontological modeling language. So I put here the link so you can check it. And here they have some tutorial examples that are not linked from the direct page. So if somebody wants to use it, I put also here the link because it's not so easy to find it. So this language is inspired by the OLL and Swirl. Its abstract syntax is defined with the ECORE. So ECORE is actually meta model from which we can generate domain-specific languages. And it generates automatically Java API and integrates additional useful APIs inside of Eclipse environment. API is published as a Maven dependency. It has default serialization is in XMI, and it works with the standards from Eclipse modeling frameworks like OCL, QFL, ATL that can help us in transformation and generation capabilities of the framework. It supports textual syntax with text, and it supports giving the graphical syntax of the ontological DSL using Sirius framework. So these are some analysis services that are native to the platform. So we can actually use tools to generate HTML documents we can merge the data sets from different projects and validate these data sets according to the specified rule sets. We can run internal servers. We can find the differences and report the differences between the different data sets. We can load existing OLL data sets. We can query with SPARQL endpoints, and we can use shackle validation environment. Also, we have direct adapters to create a core and import existing a cores to the OML. So this is very helpful when we want to hook up the domain-specific information about the technical environment. We can have a adapter to generate OLL, so we can always from here go back to OLL format and use other tools. And we have a Papyrus adapter. Basically, Papyrus is supporting UML reasoning. So regarding modeling process, so main characteristic of process that it should be developed iteratively and incrementally. It should be based on real-life projects. So we should just add and remove what we need or don't need, and to be able to start from scratch and from existing ontologies and data sets. So here I have a process, and I will go step by step through this process by the motivating example that I prepared. So motivating example comes from the ADAVEC project on which I was working last year in collaboration with different companies here from Sofia. Actually, idea was to develop a driver model for takeover requests in autonomous vehicles. So when we think about the process, first is to actually identify a needs for user profiling or creating user profile. So on these projects, we have a notion what is called the fullback ready user. So this is the user that has a minimal awareness necessary to take over the control over the car when it is in autonomous mode. So basically, this requires that the driver has a feet on the pedals, that hands are on the steering wheel, that eyes are on the road, and that he is mentally ready to take over the control over the car. So this is the scenario representing three components. Basically, it starts when we are in autonomous driving mode and the driver needs to take over the control. The cabin needs to check if the driver is ready. And we have a monitoring system supported by different cameras inside, where we want actually to understand that he has all these properties satisfied. So this is the typical example we start when we think in the system development about user. And now idea is to create and extend the user profile ontology. So from starting for now from the main dimensions that I analyze. So we have, we call it in this project high-level features and long-term properties. So something that I was presenting on dimensions is more on the left. So certain demographic information that we need from the user, certain minimal characteristics. So we know which type of alert will be transmitted. Role is obviously the driver, so we want to fix it in ontology, and it need to have certain abilities that will know its experience, language preferences, or its experience with autonomous driving systems. And also it has obviously relation with the current autonomous vehicle model. Then we have a certain real-time properties, and when we face this, we are actually starting to think about it, we have certain ideas what we want to understand. For instance, that a person is sleepy, sick, drowsiness. So some states that we don't want for the control. But actually, this type of data is coming from IoT devices, and it doesn't have some format that we can naturally connect. And usually there is a huge tendency in development then just to keep the variable names or names in the data structure that came from the device outputs. So here we actually also introduce the subcategorization from the Hackman ontology to also have a subcategories of these certain properties we want to study. And now we want to capture and map this user profile data. So thinking about high level or more static features, because no features are completely static, as we saw, they can change. We can get this type of, let's say, data format, and using the semantic ontologies, we can think, for instance, to how we want to capture this data from the driver, and for instance, do we want to generate a questionnaire that will be connected to the monitor in the car that user need to fill. So we will think about, for instance, maybe using NLP techniques to do this automatically. And then on the other hand, we have these dynamic properties that are represented usually as a triple of variable, timestamp, and confidence. And this is usually saved as time series database, and we want to understand how we can work with this type of data as well. So now we want to implement data storage and retrieval. So basically, we have a data structure envisioned, and we are creating the user model, and we have a certain set of questions that we want to get answers. So we want to, in OML native, is to collect the data in RDF, create queries in Sparkle, and to generate reports in JSON. And also we can think about different data mining techniques from machine learning that can help us to actually think about clustering, classification, association rules of this data. And finally, we want now to test and integrate this user model in the system. So this is, for instance, system in ADAVEC project. So simulation environment looks like that. So first we will need to do unit testing or to generate and use existing data and test this with Sparkle queries. So we can to show that we can generate correct reports. We want to do integration testing, so to test the collected data is working property, so that camera capture correctly information in the user model, or to test that the cabin receive the analysis reports. For instance, what is the time delay that we receive the answer from the Sparkle queries. And finally, when this testing phase is done, we want to test all the system with the scenario I introduced in beginning, and maybe focus on some usability tests and other high-level tests of the system. And finally, we get to the phase of iterate and refine. So in this illustration, actually, we didn't talk yet about the domain-specific attributes. So we want to do mapping of domain ontologies from UML diagrams, existing DSLs that describe the system, that are actually these core models that are native to the platform. And we want to analyze the rules and relations in between supported attributes, so from general ones and domain specifics. So here are some examples, like behavior is a driver reaction when the system alert is transmitted. So we want to actually memorize the sequence of the actions. We have the interest, for instance, if a driver can have interest to make his own custom alerts. It can have a preference to, for instance, auditive signal because of hearing problems. It have a certain goal or task in this scenario, and that is to take over control of vehicle when the alert is transmitted. Environment, it takes the system environment that was presented before. So usually this is already described in UML diagrams and can be automatically imported. And we have requirements that talk about the response. For instance, that can specify response time related to the specific reports that is required from the system to operate functionally. So to conclude, user profile methodology is expected to help developers when creating user profiles. We want to provide standardized terminology for this representation, so it can help developers and other non-experts in human factors field to create and use the same taxonomy. We want to enable sharing of user models and collected data and support federation and linking of existing user data. So currently I am focusing to identify more detailed structure of this meta model and to analyze its relationships, especially in between different components, to incorporate mapping capabilities. So to do tests on the existing examples that I provided with data linking, and provide the auto-generated modeling environment to using Open Caesar project. So I already start working with this implementation. And finally, to test the feasibility of complete implementation based on the examples from existing ontologies and the data that I have from ADAVEC project. So thank you for your attention. And do you have some questions?
Yes, thank you very much. Stop the recording.